Hello, little freshmen. Welcome back to the House of M. You're stuck with me today, Miss Mange. Mr. Martineau is videoing for me. So all this week we've been talking about waves, and waves are motions that repeat, whether it's ocean waves or a pendulum swinging or a rocking chair rocking or my heart beating. It's things that repeat and in the meantime transfer energy. What we need to look at today is graphs of waves. So we're going to show you a bunch of different graphs of waves, talk about how to get information from them. And that's what your assignment is today. Your classwork today is graphs of waves. So we're going to show you the first one, okay? And this graph of a wave has the typical shape we think of when we think of an ocean wave, but not, I'm not going to say that. And it does start at our origin, 0, 0. On this x-axis, we have position in meters. This side is displacement in meters. And we can get some information off here. So if I asked how many crests this particular wave has, we can count them. 1, 2, 3, 4 crests. We can figure out the number of troughs by counting. 1, 2, 3, 4 troughs. We can also figure out the wave height, and height is always vertical, so we use the y-axis for that. So if you went to the doctor's and the doctor wanted to see how tall you were, you wouldn't lay down on the table, you'd stand up. So we need to look at the y-axis, and this particular wave, this is its highest point, this is its lowest point, so this is its wave height. And it goes 2 meters above the x, 2 meters below the x. So that's a total of 4 meters. So its wave height is 4 meters. We can also get the wave length from this, which is the length of one wave. So if I started here at 0, 0, I'm moving up toward the crest. Let me get a different highlighter. I'm moving up toward the crest. So one complete wave is the same point on the next wave. I'm moving up, toward the crest. I went a little bit too far. So one wave ends here. This is one wavelength. So it is 1 meter long. That is one wave. This is many waves. This is one wavelength, the distance from one point to the same point on the next wave. If you'd rather use a crest, start at a crest and go up to the next crest. This starts at 2.25. This ends at 3.25. It's still 1 meter of distance. We can count how many waves exist on this graph. Again, if we start here, one wave ends here. The second wave ends here. The third wave ends here. And fourth wave ends there. So there are 4 complete waves on this graph. Okay.
If you start at 0.
If you start at 0, if you start here. Let's see. Something else we can get from this graph is amplitude. And when we measure amplitude, we always start at the x-axis and see how far it is to the crest or how far it is to the trough. If I start here, I'm going to move down one. If I start at x, this is the height of the crest. That's going to tell me that my amplitude is 2 meters. If you would prefer to use trough, well, here's the trough. I have to go up to my x. That distance is still 2 meters. So the amplitude of this wave is 2 meters, and amplitude is always half of the wave height. So if my wave height is 4, half of that is 2. My amplitude is 2 meters. Okay, so there are some questions down here. It says mark one cycle of the wave. That means one wave. I did that here. This is one cycle of the wave. What if I started here? This is one cycle of the wave. If I wanted to start at the trough, this is one cycle to the next trough. If I start at 0.75 meters, where does the second cycle end? Well, I'm starting down here at this trough, and it's asking me where does the second cycle or wave end. So if I start at the trough, one cycle or wave ends here, but it's asking me for the second. So I've got to go another complete wave. So the second cycle ends at 2.75 meters. Number of complete cycles means number of complete waves. We already figured out that that was 4. Wavelength, we've already figured out. The distance from crest to crest, we said was 1 meter. Amplitude, we already figured out. We said it's from the 0 to the crest or the 0 to the trough. So we said that was 2 meters. And it's giving us frequency, and it says find speed. I'm going to switch sides with you. So the formula is V equals F lambda. Speed equals frequency, which is given, times lambda, which is wavelength. We figured out the wavelength. So I was given the frequency, and we figured out the wavelength. So the speed of this wave is 4 meters per second. Okay? So this particular graph starts at 0, 0. Not all wave graphs do. This one is still the graph of a wave, but it starts up here at 0, 4. Everything is still the same. It does not change crests and troughs and any other information. We still figure out everything the same way. If I ask the number of crests, count the highest points. 1, 2, 3 crests. Troughs, there's only 2. The number of crests and troughs do not have to be equal. If I want the wave height, this is a little bit trickier. You have to be careful. The crest of the wave is at 4. The trough of the wave is at -2. But we want to know how many meters there are from -2 meters to 4 meters. And that's a total of 6 meters. 1, 2, 3, 4, 5, 6. There's 6 meters or 6 steps on a number line from -2 to 4. So this wave height is 6 meters. So we just can't look and see where a crest is. You have to be aware of the graph and look at it before you answer questions. But it's always the distance from crest to trough. Wavelength, again, if you want to measure from crest to crest, we can measure from this crest to this crest. It started at 0 meters. It ended at 2 meters. So our wavelength is 2 meters. How many complete waves are on here? Again, if I start at a crest, one wave ends at a crest. The second wave ends at the next crest. There's 2 complete waves on here. Amplitude, again, be careful. Amplitude is always half of the wave height. Well, if I said my wave height is 6 meters, the amplitude is 3 meters. So I'm really kind of dividing the wave in half. There's 3 meters up, 3 meters down. So amplitude is half of the wave height, which is 6 meters. So amplitude is 3 meters. Let's see, mark one cycle of the wave. Again, if I start here, I think the pink one's better. If I start here, that's one wave. What if I started at the trough instead? What if I started down here? Then that's one wave. So it depends where I start. Either way, this is a distance of 2 meters. This is a distance of 2 meters. It doesn't matter where I want to measure my wavelength. So mark one cycle of the wave. I did it a couple of different ways. Starting at 1 meter, where does the next cycle end? If I start here at the trough, I need to end at the trough. So my next cycle ends at 3 meters. How many wavelengths long is the graph? It's asking how many waves are there. This is 1 wave. This is 2 waves. So there are 2 complete waves. Wavelength, the length of one wave, if I start at the crest and go to the next crest, it is 2 meters. So I'm reading these right off the graph. Amplitude we discussed. We said the wave height is 6 meters. Half of that is the amplitude. So that is 3 meters. Math again. If they give us frequency, they want speed. V equals F lambda. Speed equals frequency times wavelength. That's the Greek letter lambda. They gave us frequency. We figured out lambda. We figured out the wavelength. We said the length of one wave is 2 meters. And if I multiply those, I get 1 meter per second. Yeah, Mr. Martin, thumbs up? Yeah? All right. Maybe you've noticed that the past two graphs I've shown you have had position in meters, position in meters. This one's different. This one has time. So we can get other information from this graph that we couldn't get from the other two. Once time is on the graph, we can figure out period and frequency of the wave. I'm just going to put a little note here. Frequency is measured in hertz. And I always think of it as cycles per second. How many waves happen every second. Period always means time. It's the time for one wave. They are related. It gets confusing. If you can remember that hertz is cycles per second, how often the wave happens, then it helps me to remember that period is time for one wave. So they're related, but it does get confusing. So this graph starts at 0, 0 again. Okay, and we can do crests, 3, troughs, 3. We can look at wave height. Again, it's easier on this one, 8 centimeters. Amplitude would be 4 centimeters. How many complete waves? There's 1. There's 2. There's 3. So there's 3 complete waves on here. And it says mark one cycle of the harmonic motion. So that just means one cycle of the wave. Harmonic motion is motion that repeats. That's one cycle if I start here. What if I start here? Oh, that's one cycle if I start at the crest. Okay. It says starting at 1.5 seconds, where does half a cycle end? Well, if this is a whole cycle or a whole wave, half the wave is here. So this is half of a cycle. If I start at 1.5 seconds, half of the cycle is at 2.5 seconds. Okay, number of complete cycles or waves, we counted already. 1, 2, 3. So there's 3 complete cycles or waves. Period. Period is the time for one wave. If I start here and trace out one wave, how long did one wave take to occur? It took 2 seconds. What if I wanted to start here? If I start at 2.5 seconds, trace out one wave, it ends at 4.5 seconds. 4.5 minus 2.5 is still 2 seconds. So use whichever way you are more comfortable. Frequency means the number of cycles in 1 second. Find 1 second. How much of a wave has occurred in 1 second? This is one complete wave. How much of this wave has occurred in 1 second? To me, it looks like half. So I would say 0.5, and it's hertz, waves per second. In 1 second, there was a half of a wave. A whole wave took 2 seconds. And the last thing is amplitude. We said the wave height is 8 centimeters. Half of that is 4 centimeters, or go from 0 to a crest, 0 to a trough. So it's 4 centimeters. And just for a little hint, if I know frequency and I know, no, I won't even say that because I don't think they have to do that. Never mind. Okay. Just forget where I was going to go with that. Okay. Anything else we need to add?
That's all I can think of.
That's all. So your classwork today is exactly what we did. We gave you a couple of graphs and we asked you a bunch of questions. One of the graphs starts at 0, 0 and goes up. And I think the second graph starts at 0, 0 and goes down first.
I don't remember.
Yeah. Either way, it does not change how you figured these things out. But just what you have to be careful of is where the midpoint of the graph is. Mm-hmm. Always check, is it centered on the x-axis or is it centered on something else? So be very careful about that. Other than that,
all right.
Is that it?
That's it.
All right.
All right, cool guys.
Have a great day.
Yep, we'll see you next time. Bye.